One, so this will serve our continuation discussion for analytical chemistry. So as I've said, for analytical chemistry is not all about the only with the instruments or tools pertaining to how to calculate or how to measure a certain substances or a certain reagent, but the most focus of this field is to calculate or how to calculate or measure a certain reagents or a substance, not only by the instrument that we will be using on calculating or measuring, but also on how can we calculate or what are those formulas that is pertaining to a certain formulas that is pertaining to how to solve a certain problem. So I gave you a pre-recorded video for you to easily understand each calculations, kasi as I've said, it is quite easy, but um, it is it is quite easy, but for you to understand it well and in easy form, I pre-recorded it for you to repeat it again and again if you did not get what or if you did not get how to calculate it. Kasi the calculation is very easy. It includes division, multiplication, conversion. But the thing is, there is so-called a formula on how to get it or how to calculate it, and that formula is quite for you to understand it easily. Kailangan iulit-ulit na lang natin or mauulit nyo kapag naka-pre-recorded video siya. And some of the calculation here that I will be discussing is reverse to the other calculation. Magkabaliktad ang formula, ibaliktad on how to calculate yung isa naman sa umpisa. So that's why I gave you a pre-recorded video for you to repeat the lesson. And if you have some question, you can definitely raise it on our GC or even in our even you can direct message me. So we've already discussed the introduction for analytical chemistry and basic tools for analytical chemistry. I've already gave you or introduced to you the SI unit or International System Unit. I've already gave also the picture, right? The illustration pertaining on how to convert a certain kilogram or a certain SI unit. So I hope you familiarize all of that because here in this topic we will convert or we will be going to use conversion in this kind of a topic. Okay, so conversion, division, multiplication is involved in this topic. Okay, with that, let's begin our discussion for chapter 3 or lesson 3, concentration of solution. In concentration of solution, or how can we get concentration of solution? Of course, we'll be going to undergo with a certain calculation. So the very first question that I will be arising or asking to you guys is how to calculate this concentration of solution. By that question, there is a specific process on how to calculate the concentration of solution. And how? By the means on what, where, or how much the chemical composition of a certain substance or a certain a certain reagent. And with this kind of question, there is also a involvement of calculation or steps on how to calculate a certain concentration of solution. With that, let's now begin on the formulas. Or what are those formulas that is involved in the concentration of solution? Of course, number one is density. As we all know, density is a physical property found by dividing the mass of an object by its volume. So what is the formula for density? Density equals to mass over volume, or P is equals to mass over volume. Unit for density is kilogram per meter. Okay? So an object with much matter in a certain volume has a high density. An object with a little matter in the same amount of volume has a low density. So in this kind of statement, we'll literally differentiating on how can we identify if the certain substance or a certain reagent has a high density or has a low density. So meaning to say, if the matter has a much more matter in a certain volume, it has a high density. But if it has a little matter in the same amount of volume, meaning to say the density of it is low. Okay, always remember that one. So before we will go to calculate the concentration of solution, of course we will definitely first know the formula of the given calculation, kung anong gagamitin mo. So for the density, we have density equals to mass over volume, or to simplify it more, P equals to M over V. Okay, so let's move. So the explanation, to be explain it furthermore for the statement about high density and low density, that as I've said, if there is a much more matter with the same volume, of course the density will be on high. Like for example in this third bottle, di ba? Lumubog ang matter, lumubog ang matter nung nilagay siya sa tubig, so meaning to say there is a high density. If we compare it into a little more matter, if you put a little more of matter in the same volume, meaning to say it has a low density. So the two bottles express the low density. So even if the matter here in the first one has a holes, it the same. Lulutang pa rin siya. Because again, kapag maliit lang yung matter or magaan ang isang bagay, meaning to say there is a low density na nangyayari. Pero kung mabigat or there is much more matter na mas mabigat sa volume na nilagay mo, meaning to say mas high density siya. So this illustration will explain the statement on the high density and low density. Okay, let's proceed. A mass, of course, in density there is also a formula for mass. Mass is a quantitative measure of inertia, a fundamental property of all matter, amount of matter in an object. Formula for mass, we have mass density times volume. Or to simplify it more, we have M equals to P times V. What is the unit for mass? We have kilogram. So this is constant. So this is very important for you to know what are those formula pertaining on the density, mass, and volume. What if in the certain question or in the certain calculation, you will be looking for the mass, you will be looking for the volume, you will be looking to the density. So this preparation, this will prepare you on the formulas that you will be using. We've already know what is the formula for density. We've already know what is the formula of mass. So now, let's unlock the formula for volume. As we all know, volume is a quantity of three-dimensional space enclosed by a closed surface. For example, the substance, like solid, liquid, gas, or plasma, or even the shape, occupies or contains. So for the formula for volume, we have mass over density. And to simplify it more, we have V equals to M over P. And unit for volume, we have cubic meter. Okay? So, since we already know the different formulas for density and mass and volume, let's now summary the formulas. So, for the density formula, we have density, mass, and volume. So, for the density number 1, you have to divide the mass and volume. For the mass, you have to multiply the density and volume. And for the volume, you have to divide the mass and density. So, this triangular image here will definitely show the summary formula for density and mass. If you will be looking for density, the mass is divided into volume. If we will be looking for the mass, the density will multiply to volume. If we will be looking to a volume, the mass is divided into density, right? So this triangular form will definitely give you the summary formula for each term, for density, mass, and volume. So now let's try to solve. So since it's very easy, it's very constant that I gave you the three formulas, I gave also the summarization on how can you get the formula by each terminology. So now let's solve. So example, find the mass of piece of metal that has a volume of 1.25 cubic meter and a density of 3.2 kilogram per cubic meter. Okay, given volume, of course, there's a volume here, 1.25 cubic meter, and for density, there is a given also 3.2 kilogram per cubic meter. So what would be we're looking for here in this question number 1 is the mass. So the formula for the mass is mass equals to density, sorry, it's P, density multiply it to volume. So the solution, it's very simple, just multiply it and what, cancel those unit that is the same, then iiwan yung naiwang unit. So meaning to say, the solution would be mass equals to 1.25 cubic meter times 3.2 kilogram per cubic meter. There is a present of two similar unit. We have cubic meter, cancel, then kilogram will be remain, and the answer would be mass is equals to 4 kilograms. So the answer for question example number 1 is 4 kilogram. Diba? It's very easy. Very easy pa. Let's start with easy, then average, then the hard one. Okay? Next, example number 2. The volume of an object is 8 cubic meter and mass of an object is 84 kilogram. What is the density of the object? So it's very easy to know that the term that we'll be looking for is density. So now, for the given, we have volume 8 cubic meter, and for the mass, we have 84 kilogram. So the formula, we will be looking for density. We have P equals to mass over volume. So solution, very simple. We have 84 kilogram divided by it to 8 cubic meter. So here we have the same units, so just copy the both unit of the both measurement of the substance. So the density would be 10.5 kilogram per cubic meter. So it's very easy, right? So here we undergo with the different symbols for for calculation. We have division and multiplication. So we've already undergo with that. So example number 3. Here, this example number 3 is not the same in example 2 and 1 because here we have to convert. Conversion now is involved in this type of question. For example number 3, the density of an object is 45 kilogram per cubic meter and has the mass of 84 gram. What is the volume of the object? So given here, the only what we'll be looking for is the volume. Anong hinahanap? Volume. So for the given, we have 45 kilogram per meter, and for the mass, we have 84 gram. Since mass is in gram, so we have to convert it to kilogram. Okay? So how to convert? 1 kilogram is equals to 1,000 gram. So just multiply 84 gram times 1 kilogram divided into 1,000 gram. But before that, cancel the same unit as I've said. So from multiplication, 84 gram times 1 kilogram is 84 divided by into 1,000. We have 0.084 kilograms since we've already canceled the same unit. So our volume, our mass here now is not is from 84 gram. We convert it to kilogram, so it makes 0.084 kilogram. So for the formula, we have volume equals to mass over or divided by density. So the solution would be volume equals to given mass. We have 0.084 kilogram divided by into given density. We have 45 kilogram per cubic meter. So as I've said, cancel those the same unit. So since kilogram is the same, so we have to cancel. Then cubic meter is the unit that will be remain. So the answer would be volume is equals to 0.001866667 cubic meter. So you have to write it all, okay? Even it is repeated numbers, diba? As we all know in the mathematical calculation, if it is repeated, you have to round off it. But here in this case, in analytical chemistry, in this part only of calculation, you have to write even if it is repeated. Okay? You have to write in this part. But there is part of calculation here na you have to round off. So, I will be telling to you naman if this type of calculation kailangan na natin mag-round off. So, in this part, you have to write all of the repeated numbers. Okay? So that would be the example number 3. So that is very simple. So how can you calculate the concentration of solution? By the density, mass, and volume. So I gave you the example of the different type, and if there is so-called conversion, kapag we have to involve conversion, it's very easy because I gave you already the chart on how what are those equivalent of per kilogram, gram of even meter. I gave you already in that chart. Okay, so let's go now on percentage composition. So we've already done discussing how to calculate the concentration of solution. So now let's proceed on the percentage composition. So to prepare a substance from another substance, such as oxygen from water, the percentage composition of the source water is determined. This will give an idea as to how much of the product, which is oxygen and gas, can be obtained. How do we compute the percentage of composition of a compound? We find it form by called formula mass. So we've already done answering how to calculate concentration of mass, and how to calculate concentration of mass is by density, mass, and volume. But here, if we're talking about percentage of composition, we will be dealing on computing the formula mass. So on formula mass, it's very different to density, mass, and volume. There is a certain step here also for formula mass. So I want you to listen carefully here. So for formula mass, the formula mass of a substance is sum of the average atomic masses of each atom represented in the chemical formula and is expressed in atomic mass unit. So here, atomic masses or atomic weight is now involved. So we will be using a periodic table, but I know and I assume that you've already familiarized those atomic weight. So hindi na kayo mahihirapan with regards to this one. So element, we have, let's try to get the formula mass for chloroform. Okay, figure 1, the average mass of chloroform molecule. We have this is actually the explanation here of the solving. So okay, the example, the compound that we'll be using is chloroform. Okay, so in the formula mass, we have to divide all of the symbol or element that presented in chloroform. Ano ang meron sa chloroform? We have carbon, hydrogen, and chlorine. Okay, for element na presented sa chloroform, ilagay carbon, hydrogen, and chlorine. For the quantity, so ilan ang atomic or atom that is presented in each element. So, as I've said, as we all know in general chemistry pa, if the element has no sign, meaning to say, it has an invisible 1. 1 na kagad ang number niya. So, for the quantity of carbon, we have 1. Hydrogen, we have 1. And the chlorine, we have 3. Since here, we have the atomic unit here, 3. Okay? Get it? So, for the average atomic mass, where can we get it? The atomic mass of each element. So for carbon, you will be looking at our periodic table, 12.01. Okay? 12.01. For the hydrogen, 1.008. For the chlorine, we have 35.45. So you have, what you're gonna do, you have to multiply only the quantity and the average atomic mass. Okay? Okay. So AMU here is the unit for atomic mass unit. Okay, AMU defined as, this acronym defined as atomic mass unit. Okay, so 1 multiplied by 12.01 is equals to 12.01. 1 multiplied by 1.001 is equals to 1.008. Sorry pala. 3 is multiplied to 35.45 is equals to 106.35. And what you're gonna do in the last part, you have to add all of the subtotal atomic mass unit. Okay, from 12.01 plus 1.008 plus 106.35 is the total molecular mass would be 119.37. So meaning to say, the average mass of chloroform molecule is 19.37 atomic mass unit, which is the sum of the average of atomic masses of each its constituent atom. So the model shows structure is above. Okay, so that would be the formula mass for chloroform. Okay, I hope you understand how can we get the sum of the average atomic masses or the formula mass. It's very simple again. Nasa simple pa rin tayo. Example, another example. Determine the formula mass of the following. Chalk or calcium carbonate, or the compound would be, the symbol for the compound would be CaCO3. So let's divide it also. Let's get the symbol of the element of this compound. Element, we have carbon, check. Calcium, sorry. We have calcium, check. We have carbon, check. And we have oxygen. Again, number of atom that is presented to each element. Carbon, sabi ko nga, let's go back to general chemistry. In a certain compound, may invisible 1 agad yan. For carbon, we have 1. For calcium pala, sorry. For calcium, we have 1. Nagkakamali si ma'am. For carbon, we have 1. For oxygen, we have 3. Why? Because in the last part of this element, for example, in oxygen, we have the subunit or the atomic unit, which is 3. Nakalagay siya, so it's 3. So what you're gonna do? You will be finding also the average atomic mass or atomic mass unit. Okay. How to calculate it in an easy way sa atomic masses? Ma'am, yung atomic masses kasi ng each periodic table is not the same. Some of the atomic masses of periodic table has for example, the decimal of it is not the same. Kung sa periodic table ko, the hydrogen would be 1.008. Sa iba, may possibility na 1.007. So what we're gonna do is, kapag nakadecimal siya, just make it into whole number. How? By using round off. Dito na siya i-round off, ha? Okay. So, since first one is calcium. So, calcium, we have 40.08. Round off it. Make it into whole number. We have 40.00. Carbon, we have 12.02. Yes, 02. So round off it, make it to whole number, 12.00. Oxygen is 15.16. Oxygen, naka-whole number na, 16.00. Okay? So what you're gonna do for the next part? Just multiply the number of atoms or the quantity of atoms to average atomic mass. So 1 multiplied by 40.00 is equals to 40.00. And 1 multiplied to 12.00 is equals to 12.00. And 3 multiplied to 16.00 is equals to 48.00. So the last part that you're going to do is just add the 3 answers. We have 40.00 plus 12.00 plus 48.00 is equals to formula mass or molecular mass 100.00. Okay, for the formula mass of calcium carbonate is equals to 100. And for the molecular mass is equals to 100 atomic mass unit. So it's very simple. So that is the answer for example number 1 for the chalk or calcium carbonate. Okay, so this is how you will round off a certain decimal number. So here, for how to calculate the how to make it to round off from the how to make decimal a whole number or try to round off it. So 45.15. So 5 we can convert 5 here. We can give 1 to 1 here. Pwede tayo magbigay sa 5 ng 1 dito sa unang number. So it makes 2. So from 45.15, it will be 45.20. Always remember that if we convert, kung kahit ilan man ang ibigay, magiging 0 si 5. Okay? So, kasi magtatanong kayo, ma'am, bakit hindi siya magiging 45.24? No. Kapag mag-convert kayo, pag magbigay ng isa sa first number, magiging 0 agad si 5. So, from 45.15, cancel. Give 1 to the first number, which is 1 also, though it will make it 2. So, aside from 45.15, magiging 45.20 siya. So, from 45.20, hindi na ma-convert. So, here, we cannot round off it furthermore. So, it will have a 45 or whole number. The same strategy to this one and this one. But I know you already know how to convert, how to round off a certain number or a certain whole number. This is just a review to you. Okay, let's proceed. So another example for determining the formula mass of the following. Here may dalawang unit na tayo na may number na atom number. So for this compound or alcohol from C2H5OH or the alcohol itself, we have three element again. We have carbon, hydrogen, and oxygen. For carbon, we have 2 since it has a 2 here, subunits. We have a hydrogen since the hydrogen is there is 2 hydrogen. From the hydrogen of alcohol here, ito, this one, and this one. Okay? So, 6, let's add it to 1 hydrogen kasi sabi ko nga, each element kahit walang subunits na there is an invisible 1. So, hydrogen here for alcohol is 1 plus the hydrogen which is 5 na may subunits, it is equal to 6. So, and oxygen which has no subunits pero sabi ko nga, there is invisible 1 and it will make us 1. Okay, for average atomic mass, again, look for the atomic masses of each element. So 12, since it has a decimal here also, 12.02, convert it or round off it. So from 12.02 decimal to a whole number, so 12.00. Then, from hydrogen, since hydrogen is 0.008, convert it into whole number again, 1.00. And oxygen, which is 16, there is a whole number here for oxygen, which is 16. Hindi na kailangan i-round off kasi 16 na talaga siya. Okay? The same process, you have to multiply 24. So the total, subtotal will be 24, 6, and 16. And the totality of alcohol, the formula mass for alcohol is 46, and the molecular mass would be 46 atomic mass unit. It is the same. Okay. So if you have a question clarification, you can leave that in our GC or just PM me. So any questions, clarification. So that is how you can calculate the formula mass or the percentage composition. So, unlocking of difficulties now, we have already done knowing how to calculate the concentration of solution, and we have already done how to calculate the percentage of composition. So today, if you have question, you can leave it to me in GC or in direct message. Let's proceed now on trying this one. So I want you, on each calculation kasi, meron akong niligay na try this. This is the very first one. For the density and mass and volume, wala na ako nilagay. So this would be the first. So just write it on your paper. Any type of paper, scratch paper, it's okay. Picture it. Send it to GC. Sige na. I can see naman if that person will definitely copy what would be the first one will send. Send it to GC. Then, any time today or any time with this today and tomorrow. Okay, pwede rin siya tomorrow ipasa, okay? So for the try this, it is asbestos or hydrated magnesium silicate. So just try this one. Just try to get the formula mass and molecular mass of this compound, okay? So let's move. For the continuation, the percentage of each element in a compound may be expressed as follows. So we've already done discussing or calculating the percentage composition, and each that percentage of the element has a compound that we can express in this type of a formula. We have percentage of each element is equals to number of atoms of elements times multiply to atomic mass divided by 2 formula mass and multiply it to 100. So here, the involvement of formula mass. Again, the involvement of formula mass is existed in this kind. Kasi hindi pa natatapos in the percentage of composition, which is getting by formula mass. You will be getting also the percentage of each element. So here, the focus would be the percentage of each element. So let's proceed. Example number 1. What is the percentage composition of a sodium carbonate, Na2CO3? So the step 1, number 1 that you are going to do is calculate the formula mass. So it's very simple. I've already discussed that with the percentage of composition. Let's divide. Let's divide the compound into element. We have 3 elements presented in the sodium carbonate. We have sodium, carbon, and oxygen. So let's find out the quantity of the atom. Sodium is 2, since there is a subunit. Carbon is 1, invisible 1 here. And oxygen we have 3. So again, what we're gonna do, we will multiply it to their atomic masses. So find the atomic masses of each element in the periodic table. So 2 multiply 23, which is the atomic mass of sodium, is equals to 46 atomic mass unit. Carbon, 1 multiplied to 12 atomic mass unit is equals to 12 atomic mass unit. 3 for the oxygen multiplied by 16 atomic mass unit is equals to 48 atomic mass unit. So what would be the formula mass? So the formula mass would be 106 atomic mass unit. Bakit nangyari yon? Just add 46, 12, and 48. Just add it and the result would be 106 atomic mass units. So that would be the step 1. Step 2. Calculate now the percentage of each element. So meaning to say, you will calculate the percentage of each element. Lahat ng yun ha. So since we have 3 element, you have to calculate the percentage of the 3. Percentage of the sodium is equals to 46 over 106 multiplied to 100. So where did we get the 106? By the formula mass. So let's go back to the formula of the percentage of each element here. Here. Percentage of each element, number of atoms of element multiplied by the atomic mass over formula mass times 100. So it is the same on what we do in step 2. So the percentage equals to 46 because it is the atomic mass for 46 because it is the result for the how to calculate formula mass. Itong 2 times i-formulate mo. 2 times 23 atomic mass unit. So the answer will be 46. So dyan natin nakuha si 46. So 46 over 106 multiplied to 100 is equals to 43.40 percentage. So that would be the percentage of the element sodium. For the carbon, we have 12 equals to 106. Over or divide equals to 106 multiplied to 100 is equals to 11.32 percentage. And oxygen of percentage of oxygen we have equals to 48 divided by 106 times 100 is equals to 45.28 percentage. How can we get the totality of it? Just add the 3 result. 43.40 percentage plus 11.32 percentage plus 45.28 percentage is equal to 100 percentage. Okay, that would be the total. Example 2. So that would be the answer on the question number 1. What is the percentage composition of sodium carbonate? Okay, so now let's proceed to example number 2. What is the percentage composition of calcium carbonate? Okay, step 1. Here, calculate the formula mass of calcium carbonate. We have 1. Let's divide each element. We have 3 element here: calcium, carbon, and oxygen. Calcium, there is no subunits, but there is an invisible 1 for 1. Calcium. Carbon also 1, and oxygen is 3 since it has a subunits. So, another, the same procedure. 1 times 40 equals 40. 1 times 12 equals 12. 3 times 16 equals 48. So, just add all of that, and the result would be, the formula mass would be 100 atomic mass unit. Okay. Step 2. For the calculation of the each percentage of each element is the same procedure again. Percentage of calcium is equals to 40 divided by 100 times 1 times 100 is equals to 40 percentage. Another, for the percentage of carbon, we have equals to 12 over 100 times or multiply 100 is equals to 12 percentage. For the percentage of oxygen, we have 16 over divide to 100 times 100 is equals to 16 percentage. So just add the result, and you can get the percentage of the element. So 40 percentage plus 12% plus 16% is equal to 68%. So the percentage composition of calcium carbonate is 68%. So another question. So here, so in this example, it is not the same to the two example that I've already said, because here the question not only in solving a problem, just read and understand the problem. Okay, all of the problem or word problem is not the same. Baka maka-undergo kayo or encounter kayo ng ganitong question, iba ito nung una, pero the same pa rin kung anong gagawin. Here, what percent of hydrated copper sulfate lang ang kukunin is water. So, the only hydrated copper sulfate here is in the lower part, the 5H2O. So, but you have to get first the formula mass. So, for calcium, kasi here, there is a lot of element, right? For copper, calcium. For copper, sulfur, and oxygen. Then, the hydrated one, or the water. Okay? So, so let's give the formula mass, or let's calculate the formula mass. So for copper we have 1, for sulfate 1 again, then oxygen we have 4. Multiply the same process, but the only difference is in below. So since here in the water part there is a number of atom of a compound here, this is 5. So get the atomic mass of hydrogen and oxygen. Okay? Okay, again, bakit naging 18 to? Ma'am, bakit naging 18 yon? Of course, you have to calculate or to add the atomic weight or atomic masses of hydrogen and oxygen. Okay, that's why it's make 18. As we all know, the oxygen is 16. And as we all know, the hydrogen is 1. So there is 2 hydrogen here. So 1.00 plus 1.00 is equals to 2 plus 16 atomic mass of oxygen is equals to 18. Okay? So why there is a 5 here, ma'am? Kasi bakit po? There is a number of atomic mass of a certain compound. Sa compound na talaga to. So there is a 5 here. So 5 times 18 is equals to 90 atomic mass unit. So you have to add that one, that all of the result, we have 250 atomic mass unit. So the question would be, what percent of hydrated copper sulfate is water? So what would be the compound na kailangan mo lang isolve is the water. So the percentage of water or the H2O is equals to 90 here. 90 over 250, which is the formula mass, times 100, and the answer would be 36 percentage or 36%. So that's what I'm saying a while ago, that read the word problem first before going to calculate. Kasi maybe you will not or understand the word problem. Kasi maybe along the way, baka ang gagawin mo, the same process. No. It depends upon what is the problem looking for. Kung ano yung hinahanap ng problem. Okay? Always remember that one. Next, try this. Another item for the assignment. Okay? What is the percentage composition of the sodium bicarbonate? It's very simple. I know you get already what I'm saying. Okay. So let's go. Let's now proceed. Again, di pa nagtatapos 'yon. In determining the percentage of composition, there is a formula from percentage composition, hindi pa yon natatapos. So how? Scenario. At the times of chemist is faced with the problem of what compound is present in the plant, a report from an analytical laboratory on the present composition of the compound provides data that can be used to determine its formula. Here we reverse the process learned earlier in percentage composition. Okay, here in the scenario, as I've said a while ago, the very first thing that I'm saying kanina pa, that in analytical chemistry, it is quite simple kasi ang ginagamit lang multiplication, division, conversion, ganyan, or even ratio is involved. Pero the only thing that make it hard is that kapag yung process ibalik naman ulit, ganitong nangyayari. Kasi there is a process and percentage composition. Yung sinabi ko kanina, yung discuss ko kanina, that is the process on looking on the composition of a certain percentage. But there is a certain scenario, okay, again. So from the normal one on how to calculate percentage composition, here in determining the formula, we have to reverse the process. So dito lang siya nagiging what do you call this? Mahirap kung ibabaliktad na natin. So here, ibaliktad na natin. So an insect repellent, the butyl succinate is found to contain 63.16%. Meron na lahat of carbon. Present na siya. So we will be looking for the empirical formula niya na. Yung empirical kasi ibabaliktad natin siya 8.77% hydrogen and 28.09% of oxygen. Its molecular mass is experimentally found to be 228 grams. What is the empirical formula? So we will be calculating now the empirical formula. Yung una, sa percentage composition kanina, ang kinuha talaga natin ay percentage composition by the empirical formula. Paano natin na-solve? Of course, sa empirical formula ng each compound. Here, nandito na ang percentage composition ng each element. Anong kukunin natin? Yung empirical formula ng element. Yung compound formula ng element. So, paano gagawin? Let's start on step 1. Change the percentage or percent to mass in gram of each element in a 100.0 gram sample. Okay? So from this percentage of element, let's make it. There are three element here. 63.16 percentage. Let's make it to gram. 63.16 gram. So H8. Just change lang where I'm not saying convert. You have to change lang the unit. 8.77 is 8.77 gram. 28.07 percentage is 28.07 gram. Okay? The totality of the three, we have 100.00 gram. Number 2, convert the mass in gram of each element into number of moles by dividing it by its atomic mass. With the result, the mole ratio of all elements in the compound is taken. So this would be the solution. So the percentage of mole of carbon is equals to 63.16 gram. Ma'am, saan nakuha si 63.16 gram? Sa given percentage, right? Nag-change lang natin ng gram. So 16.16 gram carbon is multiplied to 1 mole carbon, which is constant because it's mentioned number of moles. 1 mole, it's constant. All of that is 1 mole already. 1 mole carbon over the atomic mass of carbon. What would be the atomic mass of carbon? It is 12. So from 63.16 gram multiplied to 1 mole carbon is equals to 63.16 gram again. Divide into 12 gram carbon, it equals to 5.26 moles. Okay, the same process to the mole of hydrogen. We have 8.77 gram hydrogen multiplied to 1 mole hydrogen is equals to 8.77 divided into 1 gram is equals to 8.77 mole. The same process again for the mole of oxygen. 28.07 gram multiplied to 1 mole oxygen over 16 gram oxygen. So 28.07 multiplied to 1 is equals to 28.07 gram divided by 16 gram is equals to 1.75 moles. So let's make the mole ratio. So what would be the mole ratio? It's very simple. Get the result of each element. So from the carbon is to hydrogen is to oxygen equals to 5.26 moles is to 8.77 moles is to 1.75. So let's round off it. So step 3, reduce the mole ratio to simple whole numbers. As I've said, round off by dividing each by the smallest value. Okay? So 5.26 divided by 1.75. Okay, where do we get 1.75? Of course, the instruction. Divide it into the smallest value. And what is the smallest value here in the mole? The 1.75 yung mole ng oxygen. So you have to divide it into the smallest value. 5.26 divided 1.75 is equals to 3. And 8.77 divided into 1.75 is equals to 5. 1.75 is equals to 1.75 is equals to 1. So what would be the empirical value now of each percentage? So the simplest mole ratio or empirical formula is C3H5O1. So that would be the empirical value of each percentage element that we've already calculated. And step 4, hindi pa pala natatapos. There is step 4. Find the empirical mass of find the empirical mass. Okay, the result for the empirical or the simplest empirical formula, this empirical formula is called as hydroxypropyl. Okay, C3H501, or you cannot even write it, but since it's empirical formula, just write 1 in oxygen. Okay, so now for the last solution, step 4. Uy, there is another pa pala, hindi pa yung last. Okay, for step 4, find the empirical mass. We have C3H501. What you're gonna do is equals, anong gagawin na naman? Empirical mass nang hinahanap. Very, again, easy. 3 is saan? Sa subunit ng carbon, multiply to the atomic weight of the carbon. And 5, we have 5, 1, since hydrogen, the atomic weight of hydrogen is 1 for the whole number. And oxygen, we have 1, and the atomic weight, we have 16. Okay, so now, let's multiply all of that. 3 times 12 plus 5 times 1 plus 1 times 16 is equals to 57 gram. So for step 5, divide the molecular mass by empirical mass to get the number, which is molecular. The formula will be molecular mass over empirical mass. Why? Because there is this step. Kasi there is this question na its molecular mass is experimentally found. There is a given molecular mass here, 228 grams. What is the empirical formula and molecular mass? Not only the empirical formula is being asked, but also the molecular mass. So now, molecular mass is given. We have 228 gram, and the empirical mass of hydroxypropyl is 57 gram. So let's divide it. 228 gram divided by 57 gram is equals to 4. So indicate the multiplicity of the empirical formula with respect to the molecular formula. So the molecular mass that being asked is actually 4 from the division of 228 over 57. Okay? So for the step 6, multiply the subscript of the empirical formula by the number found in the step 5 to get the molecular formula. So it is 63H5O1 and 4. Kasi we have here, right? We have empirical. We have the molecular mass here 4. So in the step 6, it's give instruction that to get the subscript of each empirical formula, um, multiply the number that found in step 5 to get the molecular formula. So just multiply the 4 here to each subunits of each element. So 4 times 3 is equals to 12. We have C12. Then 4 times 5 is equals to 20. We have hydrogen 20. And 4 times 1 is equals to 4. And we have now 4, 0, 4. Okay, so for the molecular formula here now is C12H20O4. So now it's named as dodecanedoic compound. So, yes. So that is the name. 2Z-dodecanedoic acid. So that would be the name of C12H20O4. So that would be the answer of the question that is reversed in the percentage composition. So here, diba? So the process on how to solve is very simple, but the it's like pahabaan ng proseso eh. 'Di ba? So that would be the answer for the question on the reverse process ng percentage composition. And with that, let's try this. Another item for you to be answer in a paper. So folic acid is a compound that contains 2.04 percentage hydrogen, 32.65 percentage which is sulfur, and 65.31 oxygen. What is the molecular formula if it has a molecular mass of 98 grams? So what we're gonna do? Go back to step 1 in this kind of area. Okay? So that's it. That is how can we solve the first one, the concentration of solution. Next would be the percentage of composition, and the third one is the reverse composition or reverse percentage composition. So there are 3 elements, there are 3 topics that we've already unlocked for this day. So now let's proceed on mole concept. Here, I will be introducing the mole concept, but we will be continuing our topic, this one in midterm. Pero i-introduce ko ito kasi it is part of our exam. Okay? So let's proceed. Mole, also spelled as mole in chemistry, a standard scientific unit for measuring large quantities of very small entities or amounts such as atom, molecules, or other specified particles. So mole is specifically presented in analytical chemistry kasi most of the time the measurement is in very very large number or is in very very small entities or small number. So moles has a power to do or to calculate each measurement like that. Okay, let's go now to how big is a mole. Diba? I've already introduced to you the scientific notation. So how can we make the very very large number to a simplest form, then the very very small entities to a simplest form? I've already gave to you that in the basic tools. I've already discussed that. So chemically, a mole means 602. Again, for the mole, it means a very, very large. For example, here, it's actually 602 septillion already. So how can we make it into a simplest form? Of course, by the means of scientific notation. 6.02 times 10 to the power of 23 particles. So the particles may be atom, molecules, ions, or electrons. And that is explained by the discovery of this person. We have Amedeo Avogadro made a study on this. How did he arrive at a number of 6.02 times 10 to the power of 23? So he called it as a Avogadro number. Okay? So let's proceed. So the atom carbon 12 was experimentally obtained to have mass of 19.92 times 10 to the negative power of 24, or 12 atomic mass unit. This fact allows us to calculate the number of carbon atoms in a sample with a mass of 12 grams. The molar mass of the 12 carbon in grams. So let's now solve the problem. Okay? in this statement again, so in this problem, this explains on how Miss Avogadro or Mr. Amedio Avogadro get the 6.02 times 10 to the power of 23 atoms. So this is the problem that he make. Then eventually he get the calculation, which is this one. This is the constant one, or the answer. How does Avogadro's, or how does Mr. Amedio get the 6.02 times 10 to the power of 23? So now it has a 12 gram of carbon, times multiply it by 1 atom, and divided into 19.92 times 10 to the negative 24 power. So cancel the same unit. So this is just a representation, ha. Sorry. Constant lang to. Let me rephrase what I'm saying a while ago kanina. Kasi this problem is answerable by the question, how did he arrive with the certain phenomena like 6.02 times 10 to the power of 23. Okay? To the power of 23. So this is the calculation on how does Mr. Amedio get this one, and how does this make from the problem of this. Okay, so using the different kinds of substances, he came out with the same number, which is 6.02 times 10 to the power of 23, also called as I've said, Avogadro's number. Okay, so to illustrate, 1 mole oxygen atom consists of 6.02 times 10 to the power of 23 atoms of oxygen. 1 mole of chlorine atoms consists of 6.02 times of 10 to the power of 23 atoms of chlorine. 1 mole of hydrochloric molecules consists of 6.02 times to 10 to the power of 23 molecules of hydrochloride. So this one is just a hydrochloric. This one, 6.02 times 10 to the power of 23, is very constant. So how can we tell it into short one? Is 1 mole of any element is equals to 6.02. This illustration, or this statement will answer this one, or in short, in this statement, every each element or each compound, there is 1 mole element, or 1 mole of any element is equivalent, for 6.02 times 10 to the power of 23 atoms. It is very compound. And 1 mole of any compound, it equals to 6.02 times 10 to the power of 23 molecules. So always remember that one. Ito lang yung gustong sabihin ng illustration natin dito, na lahat, even if it is an element, even if it is a compound, all of that will considered to be what? To has a 6.02 times 10 to the power of 23 atoms for element and molecules for compound. Okay? So now let's proceed to, let's solve word problems using mole concept. So how many moles are there in 3.01 times 10 to the power of 23 atoms of calcium? So given would be 3.01 times 10 to the power of 23 atoms of calcium. So that the factor or unit relationship as given in the mole concept is 1 atom calcium, since I've said that there is an invisible 1 in calcium there. Kasi all of the, kahit hindi ilagay ang subunit ng element, meron talaga silang 1, invisible 1. Over, of course, the constant in any element, there is a Avogadro's number, which is 6.02 times 10 23 atoms calcium, or 602 times 10 to the power of 23 atoms calcium is equals to 1 mole calcium. And since we are interested in the mole, we use factor A, where mole is placed as a numerator and where we can cancel atom as the denominator. So since we're looking for the percentage mole of calcium here, we have equals to 3.01, it is given, times 10 to the power of 23 atoms calcium, times, multiply it. Let's make numerator, let's make the mole as numerator. We have 1 atom calcium is equals, and the let's make the mole, or let's make the place of a mole as numerator. We have 6.02 times 10 to the power 23, because this is your mole, and the calcium as our denominator, we have 1 atom calcium. Okay, did you get the point? So from cancel to the same unit, we have atoms calcium and atom calcium. So 3.01 times 10 to the power of 23 multiplied by 1 atom divided by 6.02 times 10 to the power of 23 is equals to 0.5. So if you divide it, how can we divide it, ma'am? So 3.01 times 1 is equals to 3.01. So divided into 6.02. So the answer would be 0.5 or 0.5 times 10 to the power of 23 mole. You can use that one. Pwede sa 0.5 mole kasi in calculator that would be the answer. Or you can answer also, you can write also the times 10 to the power of 23. Okay? You can answer 0.5 or 0.5 times 10 to the power of 23 mole. So that would be the answer of the question of the problem, word problem 1. So for the word problem 2, how many moles are there in 2.408 times 10 to the power of 24 molecules of hydrochloric? So we will be finding now the percentage mole of hydrochloric. So the percentage mole of hydrochloric, we have 2.48. So we are now in the compound kasi kanina we are in the element, right? For the calcium. So that's why it's atom, not molecules. Okay? So again, as the same procedure, just cancel the same unit. We have molecules hydrochloric and molecules of hydrochloric. Cancel. So 2.408 times 1 is equals to 2.408 again. Divided by 6.02, so the answer would be 4.0 moles or 4.0 times 10 to the power of 23 moles. Okay? So that would be the answer. So, yon. So that would be the answer for question number 2. But here part, kasi there is a confusing here kasi you will be literally asking me na, ma'am, what hindi magkapareha yung power ng both number. So in this part, pwede na siya na you will stick onto 4.0 moles. Just stick with that answer. So if it is the same if there is the same in their power, so it's okay to write that times 10 to the power of 23. Like for example this one, pwede mo siyang gamitin 0.5 or 0.5 times 10 to the power of 23. Ganun lang. So this part, para lang, let's avoid this so-called confuse in here part. You can stick on 4.0 moles here. Pwede mo na yan lang ang isagot mo kapag hindi magkapareho ang power ng both substance. Okay? So that's it. That is the answer for the question number 2. Try this. So another item for our assignment for number 3, how many atoms are there in 4 moles of chlorine? 4, how many molecules are there on 1.5 moles of water? So it's very simple kasi I've already gave the examples. And for our next topic for the next midterm or for the next a lesson, we have molar mass, molar volume. So try to look for the definition of each terminology for you to know along my discussion in that time, for you to know na this list. Okay? We have topic molar mass, molar volume, molarity, percentage by volume or by mass, mole fraction, molality, and normality. Now, we are going deeper by deeper in each topic. And each topic has a calculation. So, I hope you can stand by in this time of lesson. So, the reason why I gave a pre-recorded video for this part, because I want you to repeat what is the process of the calculation kasi it is not easy to calculate something. Always remember that one. Numbers is quite hard if we deal with that. So for us to make it easier, so I make it a pre-recorded video. So thank you very much everyone. So thank you for watching. the video, and if you have question clarification with regards to the topic or the calculation itself, just ask me on GC or you can PM me directly. Have a nice day, everyone. Thank you.